So what we're going to do is look at basic M mode, over the next few sessions, and then we can go on to a little bit more advanced M mode. So when we say M mode, we mean motion uh, mode. It's the earlier form of echo, and you know when 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 echo was first conceived of, and you did your scanning, you didn't get your two-dimensional images as you get today. You used to get these still frame images, and you get a lot of information from them. So we're going to go backwards now. We're going to learn it. Okay. First of all, you have to know what the normal M mode structures look like, and then when you have pathology, you can determine the pathology. So first we're going to look at normal structures, then the different pathology, and the pathologies are classic. We're going to look at aortic stenosis, bicuspid aortic valve, aortic insufficiency or aortic regurgitation, mitral stenosis. They love these things on exams, and you're going to get a couple M mode on exams. They love it. They're going to give you classic images. Okay. All right. So also hypertrophic obstructive cardiomyopathy, left atrial myxoma, systolic heart failure, pulmonary hypertension, pulmonary stenosis, and cardiac tamponade. So the thing about it is only, probably 12 classic M mode features they can bring. So once you learn these M mode features, you're on your way. But you should try and go a little bit above and beyond so that you have a thorough understanding of M mode. So again, when we talk about M mode, it's a time motion mode, and you'll see that on the vertical axis you have distance or displacement, and on the horizontal axis you have time. It was initially thought of the ice pick view of the heart, and that is because how it got started. They would in a cadaver they would stick an ice pick um, in portion of the heart, image it, and then when they open, they look and see what it corresponds to, and that help them to determine the different structures. Again, on the vertical axis, you have distance or displacement, and on the horizontal axis, you have time. Just like anything in echo, it is gated. That is, it's either systole or diastole. Remember, when we say something is diastolic, we're talking about you put the marker at the onset of the QRS, and that is the end of diastole, where the mitral valve is open. And then, but the duration of diastole on your ECG is from the end of the T wave to the QRS. And when we say systolic, the mark is usually on the peak of the T wave, but we know the duration of systole is from the QRS to the end of the T wave. All right. Another important exam question is that your M mode echo have superior temporal resolution as compared to your two-dimensional echo. And when we do ultrasound physics, we'll go into this a little bit more. When we talk about temporal resolution, it's a time thing. And the better the temporal resolution, you have more frames per second. Again, we're going to go over this when we do ultrasound physics. So when we do two-dimensional echo, we usually use up to say 100 frames per second to do your two-dimensional echo. the first set of M mode echoes that we did, we used about 3,000 frames per second. So yeah, M mode have much better temporal resolution than your two-dimensional echo. That's another exam question favorite. Um, so the normal M mode. So when we do M mode today, it is usually with two-dimensional guided. You know, when it was done a million years ago, there were no two-dimensional echo because remember, M mode echo came first, so there was no 2D guided M mode. So it was done blindly. The problem with that is you were, you know, when you do your measurements, you were not perpendicular to the structures and your measurements were not uniform. But if you do M mode with two-dimensional guided, you can get much more accurate measurements. So when we do or two-dimensional guided, so what we do now is two-dimensional guided M mode. And if we look at the mid left ventricular cavity, so on top you have your two-dimensional image, which is a parasternal long axis view. Again, this symbol represents your transducer or your probe. This is your two-dimensional image, parasternal long axis. Again, RV cavity. Well, first of all, you have the chest wall. Below the chest wall, you have your RV wall right there. Then below the RV, this is the RV cavity. This is your ventricular septum right there, left ventricular cavity, and your posterior wall, okay? This is your cursor which crosses all these structures. So these are the structures that the M mode is going to look at. So again, this is the cursor, and the cursor crosses. So again, this is your probe. So your probe after, and the structure that we're looking at is where you have your cursor. So the first thing that the ultrasound beam encounters is the chest wall. Then from the chest wall, it encounters the RV, the pericardium, then the RV wall, then the RV cavity, the septum, LV cavity, and the posterior wall, and the pericardium. So if you look down below where you have the M mode, again on the vertical axis, you have distance, and this is divided into this look like millimeters. So each of these, sorry. So this is I think 160. So this is be 2, 20, 40, 60, 80, 100, 120, 140, 160. So it's 160 millimeters. So each of these markings is 20 millimeters. So on the vertical axis, you have distance, and on the horizontal axis, you have time. Okay? So you can measure the thickness of the chest wall if you want to. So it's close to 20 some, probably 22 millimeters. Below the chest wall, so all of this represents a chest wall. Below the chest wall, you have your pericardium. And then below the pericardium, you're going to have the RV wall. So the RV wall is right down here. Below the RV wall, you have the RV cavity, this is the RV cavity. Then you can see that the cursor crosses the RV cavity, then it gets to the septum. So this is the septum, okay? And the reason why the septum is wavy because in diastole, the septum moves away from the posterior wall, and systole it moves towards the posterior wall. So it has a wavy movement, but it's a consistent and a purposeful movement. So again, in diastole, the septum moves away from the posterior wall In systole, the septum moves towards the posterior wall, and that's what you expect when the heart contracts. So again, this is the septum. Uh, this is the LV cavity because that's what the cursor is looking at. LV cavity is there. Then from the LV cavity, you have the posterior wall. So this is the posterior wall down here. Okay, and the same thing. The reason why it has this waving motion because in diastole it moves away from the septum. In systole it moves towards the septum. And then below the, or so that's your RV wall right there. RV cavity, ventricular septum, LV cavity, posterior wall, and that's your pericardium. So you could actually do measurements. So if you want to do measurements, you can do measurements because remember we say on the vertical axis it's distance, and each of the markings are 20 millimeters. So you just measure how thick the thing is, and your EKG, ECG is on top. Okay. Remember everything is gated, so you can measure. You can do diastolic measurements and you can do systolic measurements, okay? So if we're going to measure the septum, okay, remember, and again, this is exam type thing, septal thickness is measured at the onset of the QRS, and diastole, so you look where your ECG is, at the onset of the QRS, you measure the septal thickness, that's the thickness of the septum. You measure your LV cavity size in diastole at the onset of the QRS. So remember, these measurements are crucial and they always bring it in the exam. So the septal thickness is measured at the onset of the QRS, LV cavity size in diastole, onset of the QRS, and then the posterior wall thickness also at the onset of the QRS. The onset of the QRS is end diastole. When you're doing your systolic measurement now, you find the lowest portion of the septum because in systole, the walls are going to contract. So the septum is going to contract and it's going to move down towards the posterior wall, and the posterior wall is going to move up towards the septum. So where they are narrowest, so the lowest portion of the septum, you just drop a perpendicular to the posterior wall, and that is your LV cavity size in systole. All right, so you have to know how to measure your, what structures you're going to measure at the onset of the QRS, and how to measure the other cavity dimensions. Now we move from the mid cavity level to the mitral valve level. So this is M mode at the mitral valve level. Again, your transducer is right up here. Okay. Two-dimensional parasternal long axis view is right there. This is the cursor. We just move the cursor over a little bit. So the structures that the cursor is gonna cross is the chest wall, the pericardium, the RV wall, a little portion of the RV cavity. It's going to cross the septum as well, and then it's going to cross the LV cavity, but it's going to traverse, or it's going to look at the mitral valve, the anterior mitral leaflet, then the posterior leaflet. Okay, so when we come to the M mode structures below, again, the first structure is the chest wall. Below the chest wall is the pericardium. Below the pericardium is the RV wall. Below the RV wall is the RV cavity. Below the RV cavity is the septum. So these are the same structures that the cursor is looking at. So this is the septum. Okay. This is the LV cavity right there. But inside the LV cavity, you have the mitral valve. The mitral valve. And then you we can get if it crosses the left atrium, so this will be the left atrium right down there. But if we analyze the mitral valve in a little detail, again, everything in echo is gated. So if you look at your ECG on top, if you can't see it well, I'm telling you that the mitral valve opens in diastole, closing systole, opens in diastole, closing systole, open diastole. And this is what you know. And it's going to correspond to the ECG on top. So this is an open mitral valve. This is an open mitral valve, an open mitral valve. And we label the different points in the mitral valve. It's very important for exam and for just scanning. So this is the anterior mitral leaflet on top. So on top, that's the anterior mitral leaflet. And then the posterior leaflet is below. But there are specific points on the anterior mitral leaflet that you need to know. Okay? Again, mitral valve opens in diastole and closes in systole. Okay? All right, so these are the different points that you need to know. We have what you call a D point. And D point is the end of systole, the beginning of diastole when the mitral valve opens. Okay? So the D point is end systole because the mitral valve is closing systole. So this D point, which is right here, is the end of systole and the beginning of diastole. Then from the D point, we have the E point. So you heard about E point, and we'll talk about E point septal separation. E point is just the early opening of the mitral valve. So the mitral valve is open right there. E point is the early opening. And then you know about the E point septal separation. It's supposed to be less than 10 millimeters. Okay. If it's more than 10 millimeters, then it tells you that the ejection fraction is reduced. Then from the E point, we have the F point. And then the F point is just the mid-diastolic closure, which is right there. Then you have the A point, which corresponds to atrial contraction or atrial systole. And then you have your C point, which is mitral valve closure or closure of the mitral valve. So you can just look at it and figure out what's happening. D point, end systole, okay? E point, early diastole, early diastolic opening of the mitral valve. F point, mid diastolic closure. A point, atrial contraction or atrial systole. And your C point, which is closure of the mitral valve. Okay? So you have to know those points. Then we're going to move on from the mitral valve to look at so you can, if you look, the cursor is now over the aortic valve. But again, your transducer probe is right up here. The cursor is going to look at a number of structures, the chest wall. It's going to look at a little piece of the RV wall, the RV cavity. Then it's going to look at the aortic wall and the aortic valve right inside there. Then it's going to look at the left atrium. So these are the same structures that are represented here on the M mode. So the chest wall, you get the pericardium, the RV wall, the RV cavity is right there. So this is the aortic wall, okay? So this is the uppermost portion of the aortic wall right there. And this is the lowermost portion of the aortic wall. Inside of the aortic wall, you have the aortic valve. The aortic valve opens in systole, closing diastole, opens in systole, closing diastole. So when the aortic valve opens, it opens into this rectangular configuration. Okay, so it opens in a rectangular configuration and it closes with a straight, a so-called straight line. We call this the closure line. The closure line, and the closure line is supposed to be in the center of your rectangle. If that's not the case, it can suggest pathology. So you have to pay close attention. And you can also look at thickness of the aortic leaflets and the thickness of the aortic wall itself. And then you have the left atrium down below. You can measure, so you can measure the aortic, the aortic dimension. Okay, you can measure the aortic root dimension. You can measure the cusp, the aortic valve cusp separation, and you can measure the size of the left atrial cavity. Okay, all right. Again, these couple of statements are very important, especially for people who are going to be doing exams. So the LV internal dimension at the end of diastole is measured at the onset of QRS. So when you're measuring LV dimension at the end of diastole, onset of the QRS, LV systolic internal dimension, however, is measured at the maximal excursion of the ventricular septum, and then you drop it perpendicular down to the posterior wall. Just as I showed you before, your septal thickness and your posterior wall is measured at end diastole at the onset of the QRS. So these are stuff that we went over before. Then your posterior wall thickness, again, is measured at the onset of the QRS. That's its end diastole. The aortic root dimension is measured at the onset of the QRS as well. The AAC does not recommend using M-mode measurements anymore, but for exam purposes, they like historic stuff, so they will probably ask you that. So most of the measurements you can see is done at the onset of the QRS. The left atrial dimension, however, is measured at end systole, and you're looking for the largest distance between the posterior aortic wall and the posterior LA wall. So basically, the largest distance, so you measure it in systole from say here to this is the largest separation. Okay, but when you're measuring the aortic root is at the onset of the QRS. So you always have even when you're doing the MO, you have your ECG. All right. So we're gonna stop here. We just went over the normal structures. Our next few sessions we're gonna go over pathology. So again, M-mode is one of those things that you should understand fully, completely, because it's not a lot. It's not that you're dependent solely on M-mode for anything. So they'll just bring a few basic stuff. So you have to know the normal structures, and you have to know where you do your measurements. And then when we go into pathology, you can see the difference between your pathological M mode and your normal M mode. All right.